Hello, my name is Emily Pham, and this is my demo video for Project 1 of NGIT's CS643 Cloud Computing course for the fall 2025 semester. I've prepared a brief slideshow presentation for means of introduction, which will go over an overview of the project, the system architecture it's built upon, and how to set up AWS for use. In this project, I implemented two coordinated Java applications named CarApp and TextApp, which each run on separate EC2 instances. I then incorporated the use of three different Amazon services: SQS for communication between the instances, S3 for storing the images prior to processing, and Rekognition for car and text detection. Here is the overall architecture of my project. The public S3 bucket, which was provided in this course, contains a set of car images. CarApp scans each image with Rekognition's Detect Labels API to check if a car is present. If it detects a car, it will send the image index number to an SQS queue. TextApp, which will be running on a second instance, continuously listens to that queue. For each message received, it retrieves the corresponding image and uses Detect Text to extract text, such as license plate numbers. Both apps finish once CarApp sends a special sentinel value of -1. As previously mentioned, I used two EC2 instances with Amazon Linux 2023. Each has Java 17 and Maven installed. I also added an IAM role to grant S3, SQS, and Rekognition access, as well as had configured the security group to allow inbound SSH, HTTP, and HTTPS only from my own IP to prevent unauthorized users from gaining access. I additionally created an SQS queue and verified the S3 bucket and region were set to US East 1. With all that said, I will now proceed onto the live demo portion of my presentation. Here in my AWS console, I currently have two running EC2 instances, the one on the left for CarApp and the one on the right for TextApp. My security group, as you can see, only allows for SSH, HTTP, and HTTPS for my own IP. I also have my SQS queue named Project 1 queue ready to relay messages. Now let's start the text app first. It will wait for messages from the queue. As you can see, I've already changed directories into the proper applications for each. For the convenience of this project, I currently have my commands on standby ready to copy and paste just to make things a bit more streamlined. Here I will start the text app program. As you can see, it's now connected to SQS and long polling for any messages that CarApp sends. Now on the CarApp instance, I'll scan the S3 bucket for car images. As you can see, CarApp is using Rekognition's Detect Labels API to identify cars with at least 80% confidence. Whenever a car is found, it sends the image index number to SQS. Once all images are processed, it sends a sentinel -1 to tell TextApp to finish. All right, as observed here in the TextApp terminal, the application was successfully able to write output txt and complete. Now that CarApp has sent its results, TextApp has received them, used Rekognition's Detect Text API to extract text, and wrote the detected results to output txt. You can see here the image indices and detected text content. And this concludes my video demonstration of Project 1 for NGIT's CS643 Cloud Computing course.